So look at this. It says simplify ln of e to the 5th power. So remember that e and
Teachers at this time, please close your doors. Any students that are
can you close the door for
in
me,
your
Espinosa?
room, send them down to the main office for a tardy slip. Any students that are not in your room, please send them down to the office with a tardy slip. Teachers at this time also, please take attendance for all 9th graders. Please take attendance for all 9th graders at this time. Once you complete attendance, send them to the auditorium. If the majority of your students are 9th grade, please escort them to the auditorium. You may take photos with them as well. Again, we need all 9th graders to be taken for attendance and report to the auditorium for their photos. Thank you.
All right, guys, you got 3 main properties for logarithms. So if you have an ln and logs are brothers and sisters, so it doesn't matter. So if you have ln of a times b, that's the same thing as saying ln of a plus ln of b, your product rule. If you have ln of a over b, that's the same thing as saying ln of a minus ln of b. This is really more like exponentials because they kind of are, right? And if you have, this is a power rule, if you have ln of a to the power b, that's going to be b ln of a. Cool or not cool? So, and then remember that ln of e is equal to 1. Logs and ln, natural log, are they related? Log base e of x is equal to ln of x. So this one here, it says ln of e to the 5th. I can use the power rule, bring the 5 to the front. So what's 5 ln of e? Just 5. So that's what you type in, and then you push enter. And then, are you sure? Yes. And there it is. That's it. So let's see. Is there any tougher? Yeah, none of them are going to be tough, guys. Look, e to the negative ln of 9. That negative, okay, I guess let's screen capture this and let's do it really fast. Okay. Relax. So this e to the negative ln of, so I'm going to go ln, and that negative in the front is like a negative 1. So I can go 9 to the negative 1. Are we okay so far? And then what does this mean? Here comes your exponential rules. That means e to the ln of 1/9, right? E and ln are inverses of each other, so this is just simply 1/9. Does that make sense, guys? Bless you squared. So I come here and I just type 1/9 and I submit. How do we feel? Nothing crazy, right? So yeah, look, it looks like those are all going to be pretty basic. Let's go to the level 2. So E and ln, let's see what they have in level 2. Okay, relax. It's not extreme. Write the expression as a single logarithm in simplest form. So let me screen capture this again. And here we go. So here's what you're going to do. You see that negative 1/3? Bring it as an exponent to this. So ln of 8 to the negative 1/3 plus this 1/3, bring it right there. ln to the 125 of 1/3. Are we still okay? So that negative 1/3 means this. It means, well, I guess, okay, let's turn it positive first. ln parenthesis 1 over 8 to the 1/3. Have I confused anyone by doing that? Everyone okay so far? Plus ln, and then this means the cube root of 125. Are we still okay? So what's the cube root of 8? So this is ln of 1/2 plus ln, and then the cube root of 125, I believe, is 5. And then now because I have a plus here, that means I can multiply these. So this is ln of 5 over 2. Do you see how we did it? So I come over here. It already has ln for me. I just put the 5 over 2. And I submit. What do you guys think? Should we do another one? Yes. All right. Look at this. Relax, relax, relax. It says find the value of ln 162 in terms of a, b, and c. So we have to figure out how we can multiply these to get 162. So let me go ahead and screen capture this. Okay. All right, given the substitution ln of 2 equals a, ln of 3 equals b, ln of 5 equals c, find the value of ln of 162. All right, so ln of 162. So we got to figure out, do any of these numbers go into 162 nice and even? Well, I know that 2 goes into 162, right? 162 divided by 2. So I take my little calculator. Someone outside my room? I heard someone say something. Yeah, what's 162 divided by 2? 81? Oh, perfect. 162 divided by 2, 81. Perfect. So check it out. Big hint. 162 divided by 2 is 81, so I'm going to write it like this. ln of 162, well, I'm going to write it as, what did I say I was going to write it as? Oh, yeah. I'm going to write it as 81 times 2, because that's the same thing as 162, yes or no? So then I'm going to rewrite this as ln of 9 squared plus ln of 2, because I'm using the product rule, because there's a multiplication there. Cool or not cool? And then look at this. You see that? I'm going to move that 2 to the front. In terms of A, B, and C. Okay. So now I have 2 ln of 9, which is the same thing as 3 squared, plus ln of 2. Are we still okay? Now, do they want it in terms of A, B, and C? Okay. So I know, look at this 2 again. I can move that to the front. So 4 ln of 3 plus ln of 2. I probably did it the long way. What's ln of 3? B. And then ln of 2 is A. So I'm just going to write 4, what am I going to write? 4b plus A. So 4b plus A. I probably did it the long way, guys. Yeah, I probably, look, how did they, oh, they did it the same way. But yeah, let's do another one. Look, we're doing another one. We're doing as many as it takes for you to be comfortable with this. And we're doing them live, so we know we're not fake. So here we go. ln of 3 plus 1/3 ln of 125 is a single logarithm. This one leave alone. Bring that 1/3 right here. So ln of 3 plus ln of 125 to the 1/3. So the cube root of 125 is? So ln of 3 plus ln of 5. And then what's 3 times 5? And that's what goes in there. So like ln of 2 equals ln of 2, or A plus B. All right, let's do another A plus B, because that's what you guys want. Okay, here's another A plus B. This one, relax, guys. It's not even that bad. It just looks like it's bad. Okay, so you just separate it. So look, I see ln of 3 in there, and I see ln of 5 in there. So I'm going to write ln, this is a product, 5 times 3 to the 1/3. See? So this is the same thing as ln of 5 plus ln of 3 to the 1/3. Bring that 1/3 to the front. So it becomes ln of 5, which is a letter, plus 1/3 ln of 3, which is another letter. So what's ln of 5? And then what's ln of 3? So what am I going to write? Yeah, there you go. See, you guys are already getting a habit. C plus 1/3 B. Submit, submit. See? Like, it's not that extreme. Write the expression ln of 2 as a single logarithm. What's 2 divided by 2? So this is ln of 1. But you guys, wow, you guys know this. It's just, you're subtracting, so you're using quotient rule. Ln of 3 plus ln of 5 is a single logarithm. What's 3 times 5? It's ln of 15. So I think we got this one down, right? So now let's look at level 3. Simplify e ln of 12 minus ln of 4 and write without any logarithms. Relax. Relax. Yeah. Look, go one at a time. So I'm just looking at the exponent. ln of 12 minus ln of 4. I'm looking at the exponent first, guys. I can do what with that? Divide. So what's 12 divided by 4? So now I have ln of 3. That's my exponent. So I have e to the ln of 3. And e and ln are going to cancel out. Just drop the 3. Drop it like it's hot. Yeah, maybe that was dumb. I'm sorry. So I just type in the number 3. And then I push submit. Just like Lavelle said. See? Cool or not cool? Let's do another one. Let's see how. Relax, guys. We did a whole bunch of these in pre-cal. You guys are acting like this is like super extreme. Okay. Find the value of x that solves the equation. Okay. So here we go. You guys ready? So I have a product here. I'm going to move that 3 right there. So ln of x plus 4 plus ln of 3 cubed, and I need all that to equal ln of 9. So pretty much I'm going to get the expressions to equal 9. So this x plus 4 with that plus and that 3 cubed, I'm going to go ahead and multiply them. Yeah. 3 to the third times x plus 4, and all this better equal that 9. I'm just going to solve for x now. I'm going to divide by 3 to the third. I mean, I know what 3 to the third is, right? 3 times 3 is 9, 9 times 3 is 27. But I'm leaving it like that for now. And I have x plus 4 equals, I guess now's a good place to write 9 over 27. 9 over 27 reduces to 1/3. I don't think I've done anything crazy. I'm going to subtract 4 minus 4 minus 4. So x equals 4 times 3 is 12. 1/3 minus 12 over 3, negative 11 over 3. Before you type that 11 over 3, check that it works. If I type 11 over 3 there, will I get a positive expression? Negative 11 over 3. Well, 4 is 16 over 3. Yeah, it will. It'll work. So it's just that, negative 11 over 3. But just verify real quick. It does. It works. So watch. We come over here, we type negative 11 over 3, push submit. There you go. Cool or not cool? It's not anything extreme, guys. We'll do another one. Look, again, it's, you know what, let's look, there's the same as the other one. Let's look for something different. No, they're all simple now. Yeah, I just missed one that was different. I'll see. No, I'm looking for one that has a number minus ln. Okay, this one. So this one looks a little different. Let's see, right? Find the value of x that solves the equation, blah, blah, blah. Okay, this one doesn't look like it's going to be extreme. You see this ln of 3? I'm just going to move that to the left. So we're going to have, I'm going to move this guy to the left. So it turns ln of x plus 3 minus ln of 3 equals 1. So now I'm going to divide. So ln x plus 3 over 3, and all that equals 1. Now you can do this one of two ways. You can either remember that ln of what equals 1. Do you guys remember? Yeah, e. You can either remember that, so then that means this expression better equal e. Or if you don't remember that, be like, well, I need to cancel those ln's. How do I do that? E, and you'll still get the same thing. The expression equal to e. Do you guys see that? So x plus 3 over 3 equals e times 3 times 3. So it's just algebra. X plus 3 equals 3e. Subtract 3, subtract 3. X equals 3e minus 3. So this is about as hard as it's going to get. It's not going to get any harder than this. Let's type it in. 3e minus 3, and let's see if we got it right. 3e minus 3. I don't see any errors. I didn't see any errors. And there it is. How do we feel, guys? So can we do this first before we start taking derivatives and of exponentials and logarithms so we can get really good with the algebra? So it's supposed to take 20 minutes. Let me show you guys this really quick so you guys can see, because I don't want you guys to think that I'm fake. I'm going to click Edit Assignment, and I already created it. No, I just want you guys to know. So, Edit. So look, it gives me a time estimate. It says time estimate 21 minutes. So on average, it should take us 21 minutes to complete this. So if we're taking 40 minutes, then we might have issues, you know? So let me know if we have issues, no big deal. We'll just talk about it some more. Good job, guys. I know some of you already know what the derivative of e to the x is because you went ahead and went forward and did the delta yesterday. And if I ask you, well, why is the derivative of e to the x e to the x? Why? Like, I don't want you to be a robot, guys, so be careful. Now, I know following derivative rules can be very formulatic. Formulatic, is that a word? Because all you're doing is following a receipt. All right, Espinosa, let's close the laptop, please. So I understand that. Here's the informal proof, guys, of why the derivative of e to the x is e to the x. All you got to know is this special limit right here. And then here we go. So informal proof, well, I guess technically it might be a formal proof. All I'm doing is a derivative formula. So I want to know the derivative of e to the x. So I know that f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. And you already know that definition, right? I'm going to say that my f of x is e to the x. I'm not going crazy fast. I'm going slow. Are we still okay? So what do I need? I need f of x plus h. So I know that that is e to the x plus h. Are we okay with that? Nothing crazy, right? So I'm going to write f prime of x is equal to limit as h approaches 0. And I'm going to write my f of x plus h, which is e to the x plus h minus e to the x all over h. Are we still okay? Ratatouille and Chef Ratatouille, we're okay? Okay. All right, here we go. So f prime of x equals limit as h approaches 0. And remember, from your laws of exponents, this is if you're adding exponents, that means I can do e to the x times e to the h minus e to the x all over h. Are we still okay? Or have I confused anyone? Okay. And then from there, I see this product, and I see this e to the x. I'm going to factor out an e to the x. So f prime of x equals limit. I still haven't evaluated the limit, so I leave it. E to the x, parenthesis, e to the h minus 1, and all this is over h. This e to the x is not being affected because it's not an h. So you can leave it there if you want, but I'm going to move it to the front of this. So I'm going to write it like this. E to the x limit, because it's still a product, e to the x times whatever this limit is, as h approaches 0 of e to the h minus 1 over h. And we just said that this right here that I'm circling is nothing more than what? Than 1. So what's e to the x times 1? E to the x. So the derivative of e to the x is itself. It's the only one that's like that. Do we have any issues with this? What happened, guys? A box? No. Sorry, miss. Sorry, guys. Cool or not cool? It's the only one that's like that. So don't be a robot. So it says, so finally we have d dx of e to the x is just e to the x. So here's the chain rule. So this is telling me that e to the u is differential with respect to x. So the derivative is itself times the derivative of your exponent. That's it. That's all. That's your chain rule. And now we're going to practice. We're going to go slow. You guys ready? Okay, we're going to go real slow. So I don't know why I put so much dead space here. Maybe I should have put an extra problem. You know what? Let's put in a problem since we have so much dead space. d dx of e to the sine x. So I want the derivative of e to the sine x. What do I write? Yeah, I write itself. E to the sine x. Guys, it doesn't say space. It's okay if we're wrong. E to the sine x. Am I done? No. What's the derivative of sine x? And there it is. E to the sine x times cosine x. That's my derivative. Cool or not cool? Okay, here we go. Example 1 on the next page. And then we'll look at one that they have on the AP exam. It says, using the formula dy dx of y equals e to the x plus x squared. So here we go. Y prime, or you can write dy dx, it doesn't matter, is itself. So you write e to the x plus x squared. And then here's where some of you are going to be making a mistake. Open a parenthesis, because some of you have the habit of, times 1 plus 2x. And that is not the same. Open a parenthesis. It's a product of this. What's the derivative of x plus x squared? And make sure that's in parentheses. So it's itself, e to the x plus x squared times 1 plus 2x. And that's it. How do we feel? Nothing crazy, right? All right, this question 12 is actually from your packet that you have, but I put it in here. So 65% of the total population got it right. And you can see most of the kids that are qualifying on this exam that are getting 3, 4, and 5, the majority of them are getting it right. 70% of the 3s, or 69%. 79% of the 4s and 89% of the 5s got it right. Do you guys want to take 2 minutes to see if you guys can figure it out on your own? And it's okay if you get it wrong. We're just getting started. So give it a shot. I just figured out what I'm gonna do with that TV. I'm gonna put it in the hallway. That way, as I'm writing stuff and there's people walking across the hallway, they can see what we're working on. Right?
That'll be great for tomorrow's talk. Yeah.
And they'll be like, "Oh, look."
You have to come up here now.
Yeah, see? And they can see what we're working on and like, "Oh yeah, look what's happening." Wouldn't that be cool? So, how do we mount it? Or do we just put it in a table in the hallway? Well, yeah. Figure out how we can put that in the hallway connected to this. It's already wired. All I got to do is, right immediately right outside. Yep. Oh yeah, that's what they're working on. Okay, do we have an answer? All right, let's see if we can figure this out. What I would do first, on the side, first and foremost, guys, it's e to the 2 over x. But on the side, I would write 2 over x is equivalent to 2x to the negative 1. Yay or nay? All right, so then I'm going to write f prime of x is equal to, the derivative of that is equal to the derivative, which is itself. So itself, e to the 2 over x. And then times, am I done? Times the derivative of your exponent. So what's the derivative of 2x to the negative 1? And then notice, they don't have it written like that, so we're going to fix it where the exponent is positive. So I'm going to write, let's see, negative 2 e to the 2 over x, and then bring that x to the negative 2 down, so that brings it down, x squared. And now I look for that answer choice. Is it in there? What's the answer choice? D. So do you see how we can conquer this exam? Even if we're not the best at figuring out all the questions, we can get majority of them correct. Cool or not cool? All right, let's continue. All right, here we go. We did the algebra yesterday. So right now, the only thing you know is this. Chavs, the only thing I know right now is e to the u is e to the u du dx. That's all you know. Cool or not cool? All right, again, focus. So here we go. So we're going to rewrite this a to the x. A to the x is the same as e to the ln of a to the x. We did that yesterday, right? That's the algebra. Remember the e and ln cancel out? This is just a to the x. And then look, I'm going to bring the x to the front. So a to the x, and I kind of already typed it out for you just in case we had any issues. It's the same thing as e to the x ln of a. The power rule for logarithms. I brought the x to the front. Are we okay? All right, so I'm taking the derivative of a to the x. Well, a to the x is like this. So I'm going to write d dx of e to the x ln of a, because we know how to take the derivative of e to the x. This is the same as that, by the way. Those are the same. So here we go. The derivative of e to anything is itself e to the x ln of a. Am I done? Times the derivative of x ln of a. Chav, I don't know what that is. Yes, you do. Ln of a is just a constant. X is linear. So if I were to tell you what's the derivative of 3x, you would tell me 3. So if I tell you what's the derivative of x ln a, you're going to tell me ln a. And then the derivative of x is just 1, so there it is. This is my derivative. Yay or nay? Yay. And that's it. You're done. Okay, now let's hold on. Let's do some algebra. This right here, x to the ln of a, remember we said that was just a to the power x. I didn't freak anyone out, did I? Okay. Look, in case, if you want to see the rewrite, here it is. Here I am rewriting it. E to the ln of a to the x power. E and ln cancel each other out. Drop it. A to the x. In case you needed to see that, but I don't think you do. But in case you do, cool or not cool? Yeah, we did this yesterday, miss. I'm not judging. I never judge. Well, that's a lie. I don't judge. I don't judge for the most part. Yeah, if you threaten my life, I'm gonna judge you. So, not that anyone in here has ever threatened my life. I know I went dark really quick. I'm sorry. All right. Chain rule. Here we go. Chain rule. So the derivative of a to the u is always going to be itself a to the u ln of your base, so ln of a, and then chain rule the derivative of u, so du dx. So let's do an example. Yeah, let's do an example. Before we do example 2, let's do another one. I'm going to write d dx, and I want to know the derivative of 3 to the x squared. From up here. Yeah, it has to be any base. A is a constant. 2, 3, 4, 5, 6. It's not a variable like x. U is the variable. U is differential with respect to x. All right, here we go, guys. I'm doing an example. I just made this up. D dx of 3 to the x squared. You guys ready? The derivative of 3 to the x squared is itself. No, yeah, you don't use power rules. We're not using power rule, miss. It's 3 to the x squared. If it was x cubed, then you could use power rule, or 3x squared. 3 to the x squared is itself 3 to the x squared. And what was my base? 3. So I got to put a what on the side? ln of 3. Am I done? No. Times the derivative of x squared. What's the derivative of x squared? 2x. Leave it alone. Nothing multiplies with each other. The most common mistake is you guys say that's 6 to the x squared. It is not. Stop doing that. Don't do that. Okay, well, yeah, don't do that, ever. Are we okay? All right, here we go. Let's see how much of this we can do by hand. I know it says at what point, at what x coordinate, because we're going to do it without a calculator. At what x coordinate in the graph of the function y equals 2 to the power x minus 3 does the tangent line have a slope of 21? Okay, here we go. How do I find the slope? Take a what? Take a derivative. Here we go. Y prime equals, what's the derivative of 2 to the power x? Itself, 2 to the power x, ln of 2 times 1, but do I got to show the times 1? No. And I want the slope to be what? 21. Not the rapper 21, but okay. I'll stop. That was dumb. I'm going to solve for x because I want the x coordinate. Well, they want the point, but we're not using a calculator, so we're just going to solve the x coordinate. Are we still okay? De Leon, you okay? Ask me, miss. Ask me. Okay. Okay, well, you know that we have to take a derivative, though, right? Okay, so then you're winning. So I took a derivative. So the derivative of 2 to the power x is 2 to the power x ln of 2. All I did was follow this formula here. Remember, we did the derivation of the formula right here. So we should not be robots. It's okay to be a robot because we are just following a rule, but you should know how we derived it. Cool, Espinosa? Okay. All right, here we go. Yes, Wilson.
Oh no,
I'm gonna solve for x. So I'm gonna divide by ln of 2. So 2 to the power x equals 21 divided by ln of 2. Is everyone okay with that? Have I lost anyone? Okay, I need to solve for x, so I need to bring that x down. How do I bring the x down? With a log. I can use log, I can use log, but I'm going to use natural log because I have to write less, ln. It doesn't matter, you can actually use log. ln, whatever I do to one side, you do to the other. So it's ln of all of that, and it's ln of all of that. That's your argument, 21 over ln of 2. So that x comes down using the power rule, x ln of 2. And I know that math books don't use parentheses. We should start using more parentheses. Even Delta doesn't use parentheses, but we should. And now how do I get the x by itself? Yeah, divide by what? ln of 2. Now this is a number. X equals ln. There is no property you can use. Well, I guess you could. ln of 21 minus ln of 2, all divided by ln of 2. But don't. Just leave it like this. ln of 21 over ln of 2, lnception, because there's ln's all over the place, divided by ln of 2. This is some number. If you wanted to figure out what that number is, then you punch it in the calculator and you get the value. But there it is. Oh, what? I don't know which phone that is, but you can plug yours in if you want, if it's fully charged. Oh, it's her phone.
Are you sure?
All right.
Are you sure?
All right, guys. Focus. We're going to find the derivative of ln of x. Before I do that, I'm going to do a side note, and I don't know how we're going to do it because we haven't done implicit differentiation. So let's see how you guys fare here. So side note. Okay, you guys ready? I need your full attention for this because this is brand new stuff. If I told you that I want, so I'm going to write d dx, and I want the derivative of y cubed. But notice that I put d dx. So that means I'm taking the derivative with respect to x. So that means this is like chain rule, and I'm going to use parentheses here. So you can kind of treat it like if it was the derivative of x cubed. The derivative of x cubed would have been 3x squared, right? Okay, so look, notice where I put the parentheses. So the derivative of this is like saying, I'm going to put equal sign. It's like saying 3. And then notice the sky blue parentheses. I leave the y on the inside like that. And then I put it to what power? 2. And then you say this. Was that y an x value? Was it an x? No, it was a y, right? So you write dy dx. Or the derivative of the inside, which is dy dx. Does that make kind of sense? So look what I said. D dx of y cubed. Okay, bring the 3 to the front, y to the 2 power, and then derivative of the inside. Well, what's the derivative of y? Dy dx. That's y, the derivative of y prime. And y prime means dy dx. Yes or no? So is this kind of making sense? Okay, so I'm going to do one more side note. So look, d dx, and I'm going to write sine of y. Notice that's a y and not an x. So I say the derivative with respect to x. This is why I said the derivative of x is dx dx. Remember? The derivative of 3x squared is 6x dx dx. Okay, the derivative of sine with respect to x. What's the derivative of sine? Cosine. I leave the inside alone. And then I take the derivative of the inside. Was the derivative of the was the inside an x? No. So what's the derivative of the inside? What's the derivative of y? Dy dx. Yay or nay? Okay. It just stays like that. Yeah. If they were to just ask this, that would be a correct answer. You're going to be doing more algebra when we start doing implicit. And then when you get to something called multivariable calculus, they're going to be called partial derivatives, and that's different. You hold the variable constant. But I'll let your professor talk to you about that when you get there. But yeah, you'll see. They're simple. They're not hard. All right, so look at this, guys. We don't know the derivative of ln of x. So, Chavez, why did you tell me about this right here in the top? Because we don't know the derivative of ln of x, but we know the derivative of e, right? ln and e are inverses of each other. So look, y equals ln of x. I'm going to rewrite it, e and e. E to the y is equal to x. In case you're wondering what I'm doing something called implicit differentiation. We have not had a formal lesson. That's about 3 notes more ahead of us. But, you know, I didn't notice that I had put it in there, but I already put it in. You already know enough to be able to do this. Are we okay so far? So here we go. I'm going to take the derivative. I'm taking the derivative with respect to x. What's the derivative of e to the y? E to the y. And then chain rule, I take the derivative of the top. Is the top an x? So what's the derivative of y? dy dx. Equals, what's the derivative of x with respect to x? 1, and it really is dx dx. But dx dx is just 1. Are we okay? Well, notice what I want. I want to know the derivative, right? So I want to get dy dx by itself. So how do I get dy dx by itself? Perfect. Divide by e to the y. So I have dy dx equals 1 over e to the y. And then you're going to say this. But Chavez, I don't want the derivative in terms of y. I want the derivative in terms of x. And then you look above and look at that. What is e to the y equal to? X. So dy dx is just 1 over x. I did substitution. Sub. Does that make sense? So does that make sense? We're not robots, right? We know where all this is coming from. All right. So from now on, the derivative of ln of x with respect to x is just 1 over x. So chain rule. Here is chain rule. D dx of ln of u is differentiable with respect to x, is going to be 1 over u, and then take the derivative of u, du dx. It's going to be that forever and ever. How do we feel? All right. I got question 13. I guess before we do question 13, let's just make up an example so you guys have some exposure, and then we'll see if you guys can do this one on your own. So here, I'm just making something up. I have ln of, let's do ln of sine x. Tell me the derivative of ln of sine x. 1 over, no, not, I don't write the word ln anymore. Look, 1 over, not x, sine x. I guess I should have aimed over here. Look at your u. What's your u? Your u is sine x. So it's 1 over u, so 1 over sine x. Do you see that? Okay, now times, it says du dx, so that means times the derivative of sine x, which is cosine x. So the derivative of ln of sine x is cosine x over sine x, which would reduce to cotangent x. Cool or not cool? Okay. All right. If you want to know what is the big difference between 4s and 5s, it's questions like number 13. Chav, how do you know that? Look at the percentage of 4s that are getting it correct, just barely more than half, and look at the percentage of 5s that are getting correct, 72%. So questions like 13 is what's going to make the difference between a 4 and a 5. You have minimal experience at the moment. Do you want a shot at doing this on your own first? Or do you just go in it together because we don't have the experience yet? Going in together? Okay. Here we go. This wants a derivative of f ln of x. Before you can take the derivative, guys, find out what f ln of x is. So here we go. I'm just going f. It's a composite function. F of ln of x is nothing more than, wherever there's an x, you're going to put ln of x. Parenthesis, ln of x, close it, squared, plus 2, parenthesis, ln of x, close it. Am I okay? Nothing crazy, have I? Have I done anything crazy? No. d dx of f ln of x. I guess I could have also just put f prime of ln of x, but oh, I already started. Equals, I got to do chain rule. What's the derivative of ln of x with the power 2 up there? 2. Leave the inside alone. ln of x, close it to the power 1. Am I done? Times the derivative of the inside. What's the derivative of ln of x? 1 over x. Am I done? No, I still have this 2 ln of x. Plus 2, what's the derivative of ln of x? 1 over x. You're done with calculus. Now you just have algebra. So let's see what all this is. I see 2 ln of x over x plus 2 over x. Because my denominators are the same, I can just write them together like 2 ln of x plus 2 over x. They could have factored out the 2 if they wanted to, but they didn't. Is the answer in there? What is the answer, guys? A. How do we feel? Oh, that's your food. But yeah, I'm positive. I want you to eat. All right. By the way, guys, the domain. So we might have issues here, maybe. I hope not, but we'll see. Do you remember the domains of LNs? All LN graphs look like this. All of them, guys. Something like that. They all cross at 1, 0. All logs look like this, more or less. So your domains are all values larger than 0. So the argument must always be larger than 0. So the domain of this function here, this one that I'm looking at right here, is x must be greater than 3. From just getting your argument larger than 0. X minus 3 greater than 0. Cool or not cool? Why must we say this? Because the derivative, f prime of x, and usually, sometimes we don't even mention it, but it's noteworthy. The derivative of x minus 3 is 1 over x minus 3. The domain for 1 over x minus 3 is all real numbers but 3, guys. So if you got to state this, because it doesn't make any sense to be looking to the left of 3 when the derivative, when ln of x doesn't exist there. ln of x minus 3 looks like this. Here is 4, and here is 3. That's how ln of x minus 3 looks like. So here's my derivative. That derivative looks like this. If I were to just graph the function, right? It looks like this. 0, negative 1/3. It goes through negative 1/3, but that's fine. And it does not cross the x-axis. And that's a bad picture. It goes something like that. So it doesn't make any sense to have all this stuff over here when ln of x minus 3 only exists for x greater than 3. So that's why sometimes, I know we do a bad job of, we just take derivatives of stuff and we don't state the domain. I think College Board wants us to start putting that. They haven't taken any penalty in the past, but they always make a rubric and they say, note that the domain is blah, blah, blah. Who knows? Maybe one day they'll give us a restriction with the right domain, which actually they have asked before. Cool or not cool? Okay, yeah, so we might have issues if you feel that you're weak with logarithms and exponentials, but come in. All right, we're almost done. This is called a change of base. You remember that? Sometimes they call it change of base. And relax, guys, relax. So we know, look, I want to know my derivative. Don't worry, we're going to derive it. Yes, you can just memorize it. Log base a of x. So I know that log base a of x can be written like that, right? So I'm going to write here on the side. Log base a of x can be written as ln of x over ln of a. Well, guess what? You already know what the derivative of ln of x is, don't you? And ln of a is a constant. So I'm going to write right here, look. d dx of log base a of x is the same thing as saying d dx, open parenthesis, I'm going to write it like this. ln of, well, I guess for now I'll write it like this. ln of x over ln of a. That's the same thing, which equals, I haven't taken the derivative yet, d dx. I'm just rewriting it to make it pretty for you guys. 1 over ln of a times ln of x. 1 over ln of a is a constant, yes or no? So leave it alone. So here it is. I'm taking a derivative. 1 over ln of a times, what's the derivative of 1 over x? What's the derivative of ln of x? 1 over x. So my derivative is 1 over x ln of a. So let's do chain rule. Relax, guys. It's not difficult. I know it looks difficult, but it's not. It's not. You just need practice. So what's the derivative now from now on? If u is differentiable with respect to x, so like this. 1 over the letter u, ln of a, and on the side, times, what do I put on the side? What do you guys think? Chain rule. The derivative of u, so I'm just going to write what? du dx. That is not in the denominator, that's a product. 1 over u, ln of a, times du dx. Are we cool? Okay. No, miss. It's not bad at all, not even a little bit. Look, let's just practice. And state the domain. Okay, let's get the domain out of the way first. The expression, the argument, 3x plus 1 must be greater than 0. Yay or nay? Does everyone know that? Yeah, all logs, the domain must be greater than 0. Okay, but do we know why? Remember that logs are inverses of exponentials. Anything you raise to, okay, yeah, we'll have an algebra day pretty soon. Move the 1 to the other side, divide by 3. X equals a negative 1/3. Oh, x is greater than, sorry. So that's my domain. Are we okay? Or are we not okay? Okay, here we go. The derivative. F prime of x equals, so what do I write? I'm just following this rule right here, guys. 1 over parenthesis. Yes, 3x plus 1, close parentheses, ln of 2 times 3. Done. That's it. Let's fix it. 3 over 3x plus 1. Make sure you put your parentheses, ln of 2. Was that difficult? You're just following a rule, guys. That's all you're doing. Following a rule where x is greater than negative 1/3. That's your domain. What'd you think? What'd you think, Alvarez? Marshan, you good? Yeah. Okay. All right, and then we're done. These are just basics. You already know the power rule. So, see, so this goes back again. Don't worry. Hey, no more yawning. That's the next one's a demerit. All right, that's square root of 2. That's a constant. So that's x to the square root of 2. So the derivative of this, you can just, y prime equals square root of 2 in the front, x square root of 2 minus 1. Sometimes I put parentheses up there. It's just a polynomial. Bless you. And that's it. You're done. That's it. Yeah, it's just, it might not even be worthy of talking about it, but I decided to put it in here. All right, letter B. Chain rule. Y prime equals, that pi is a constant. It's just a number. So don't, okay. Why did I put it in here? Don't get this confused with exponentials. This is not a variable. So if I tell you, okay, don't write this down, just listen. If I tell you 2 to the power x, what's the derivative? Some of you are going to tell me in the test. I already know because every year it happens. You're going to bring the x down, you're going to go 2, and you're going to go this. No. You can only do that when it's a constant, when you have the exponent's a constant. There's an exponential function. They call it an exponential because the variable is an exponent. So the derivative of an exponential function is what we just talked about, 2 to the power x itself, ln of 2 times 1, because the derivative of x is 1. But if I have y equals x squared, well, now the 2, the exponent is a 2. That's a constant. So now this one, the derivative of that is 2x. That's power rule. This is the exponential rule that you just did. Do we see the difference? Okay. All right, sorry, guys. Here we go. Y prime equals this pi. It's a constant. It's not a variable. So I can just use power rule. Drop it. Drop it like it's hot. Pi, parenthesis. What's in the inside? What power do I raise it to? Pi minus 1. Sometimes they put parentheses just to indicate that your exponential is pi minus 1. It's fine. Am I done? No. Chain rule. What's the derivative of a sine? And I got to keep the argument. Cosine of 3x. Am I done? No. What's the derivative of 3x? 3. All put together. Y prime equals. I will put 3 pi in the front like that. Maybe put the cosine in the front as well. Cosine of 3x, giant parenthesis. 2 plus sine 3x. Close it to the pi minus 1. How do we feel? All right, guys, we're done. Take care of Delta Math. You're just doing practice. All you're doing is taking derivatives. We haven't done any application yet. So, yeah, that's all we're doing.